Hi everyone. Today we would like to present about our data group project. These are our group members: Tao Kok Liang, Yu Hao Nam, Moon Pin Pin, and Elif. Our group name is Kindling, and our group project title is Babysitter Management System. For the introduction, Babysitter Management System is a web-based platform that helps users to find babysitter easily and efficiently for the parents. It is used for finding, booking, managing, and more for babysitting service. There's four objectives for our group project. The first is to propose a system that facilitates the easy discovery, booking, and management of babysitters. The secondly is to incorporate features such as ID verification, police verification, and user rating to boost trust and security. And thirdly is to provide a searchable database with verified profile of babysitters, certifications, availability, and parent reviews. And the last is to enhance user experience to an intuitive interface for parents and babysitters. Now I want to pass to Alice to present their part.
Thank you, Lau Kok Liang. I'm going to present about problem statement. The existing babysitter booking system there is several limited features such as lack verified background checks. Second is lack of secure ID and police verification. And lastly, lack of reliable reviews. This can lead to trust issue, safety concern, and causes inefficient discovery processes. Next is the scope of our project. Firstly is target user. Target user of our project is to propose system for users that want to hire babysitters for their own children. Next, for the proposed module, we propose babysitter discovery and booking module. It facilitates the search and reservation process for babysitters. Second is verification and trust module. It's for ensuring safety and reliability checks and a user review system. And lastly, user interface and experience model. It's for focus on delivering a smooth experience for all users. Next is expected outcome of our project. The expected outcome of this project is a well-structured design of a database that display efficiently recorded and well-managed data about babysitters, kid, parents, booking, and feedback. Next, I will pass to Pimpin.
Okay, thank you. Now I will present about normalized ERD. As we all can see here, we have 5 entities inside our ERD, which is babysitters, clients, childs, booking, and of course a bridge entity for booking table and child table, booking child. Each of them has its own attributes, and every entity must have one primary key. For example, as we all can see from the DDL, inside the client table, we have client ID act as a primary key. Inside the DDL, we use comments to create a table. And whereas first thing, we declare the column name. And second, we define the data type. And last, we define the attributes of the column. For example, client ID is the primary key. Email and phone number, each of them has not null and unique. For the second example, we have booking child table. Booking child table is actually a bridge table between for the many-to-many relationship between booking and child. So inside the booking child table, booking ID refers to the booking table, while child ID refers to the child table. Both of them are also the primary key for the booking child table. Next, I would like to pass to Hao Nam.
All right, thank you, Bin. So good evening, my name is Yu Hanan, and I will continue with the parts DML and onwards. DML is typically divided into 4 categories: insert statement, which add new data in existing table; update statement, which modify existing data; delete statement, which removes data from the table; and select statement, which retrieves data. For the first example in the DML, we use in this project, which include insert statement. So we insert into child table, and inside the the brackets is the columns names, other columns names. And the values are the corresponding data that we insert into those columns. If we don't write the columns name, is fine as long as we insert the correct value into the correct columns, corresponding columns. So the second is update clients. So it's update statements. So we update clients. Then we will set means that we set these columns to this value CO2. When and where clause is the condition means when the first name is equal to Farah, we will set the client's name to ID CO2. So after that is SQL and RA. This last part consists of 4 chapters: selection and projection, aggregation and grouping, joins, and subquery. So for scenario 1, display the total number of clients served by each babysitter. We will first select columns that we want, which are babysitter ID, and we'll name it as babysitter ID. Count client ID, which we will count how many clients ID are there, and we name it as total number of clients. Then we will group it by babysitter ID, and from booking means we'll get the data from the booking tables, and order by count client ID means that we will order by the number of count client ID in descending order. So for the RA, the row denotes that if we are going to change the columns, what the column is going to be changed to. And for the reverse J looking I, it's actually before that is the group by statement, which is babysitter ID, and after that will be the attribute that we are going to change our names to. Last is the tau. Tau is the order by statement. So for scenario 2, show the name and phone number of the clients and his child's special needs and allergies, which made a booking with the babysitter with the highest hour of pay rate. So for this, we use both join statements and subqueries. So first of all, we select first name and we combine it with space and then the last name, and we name it as name. After that, we will retrieve the phone numbers, child special needs, and child allergies. And this data will be retrieved from clients. We join with child using client ID, where client ID, this part is the subquery, and the client ID will be either the client's ID, where from booking table, where babysitter ID will equal to another subquery, and the babysitter ID from babysitter tables, where the hourly rates will equal to the maximum hourly rates from the same tables. For the RA, the first will be row. As we know, just from the previous example, it's renaming the column names. And after that is the reverse I, denotes the rename columns. And after that is the sigma, which means 2 things: having or where clause. In this case, the where clause, where client's ID equal to the subquery A. Then it will join using client ID, which denotes by this reverse send clock, and the pi, which is selection, we consist of special needs and allergies from child tables, and the A, B, and C are all subqueries. That's all for me. Thank you.